Okay, so now you've had a chance to explore on your own calculator. For the website at the bottom of the screen right now is where I got this image from. And you can see in black the standard normal curve and two curves, the red one with 2 degrees of freedom, the blue one with 5 degrees of freedom. And of course, if we increased our degrees of freedom, in other words, if we made our sample size larger, you would see that it would get the t distributions would approach the same as the standard normal curve. So now let's look at conditions for creating a confidence interval with t distribution. First of all, let's look at random condition. And once again, the data comes from an SRS of size n from a population of interest or from a randomized experiment. The next condition is independent. And so the confidence interval, for your confidence interval, we're going to assume the samples are independent. And so if sampling without replacement, you of course have to look at the 1/10 rule, or 10% rule. So n must be less than or equal to 1/10 of the population size. And finally, the normal condition. The population distribution is normal. Or n is greater than or equal to 30, following the central limit theorem. So we're going to look at an example. We're going to use table B. Table B. And we're going to find the t-values for each sample size and confidence level. So in part A, n equals 5, so we need to look at where our degrees of freedom are, and it's 5 minus 1, or 4. And so now we're going to use the t-table, and I'll just pop that up. So on our t-table, at the very top you can see the distribution. We can use the upper tail probability here, or at the bottom we can use confidence levels. Whoops. So our confidence level for this one is 90%. So we're looking at this column here. Okay, and our degrees of freedom is the very first column. We're looking for 5 degrees of freedom. So the number we are looking for is 4 degrees of freedom, 2.132, right there. So 2.132. In B, n is 45, so df equals 45 minus 1, or 44, and we're looking at the 95th percentile. So we're going down to 44. And you can see that at this point we don't have 44 exactly. We said we were doing the 95th. So that's here. And we're going to use the conservative estimate, so we're going to use 40. So we get 2.021. So always go to the level, use conservative estimate of df of 40, and so t then becomes 2.021. For n equals 90, df equals 89. We're using 99%. So we don't have a 99%. We're not going to jump up to 100. We're going to be conservative, use the 80. Sorry, this was for df equals 89. We don't have a 89. So we're going to use 80, and we're going to come along until we get the 99th. So we get 2.639. So use df of 80, and t equals 2.639. Okay, for example 2, before we get to example 2, an alternative, of course, if you have a TI-84, or probably higher, is to use on your calculator the function inverse t, and using the parameters 1 minus c over 2, which will give you the tail area. So, and then df, plugging in your df value there. And of course, c would have to be in decimal value. So, in other words, if we were doing the first one, we would have inv t of 1 minus 0.9 divided by 2, comma 4. Okay, for example 2, I would like you to do the first part. You're going to describe the distribution using graphical methods and summarize the results in a few sentences. So one of the things I'd like you to sketch you can use your calculator and sketch the histogram and box diagram for that, and you are going to describe the shape, the outliers, center, and spread, and we'll finish the rest of the, you can also see if you can answer. Actually, I would like you to work through as much as you can on this, and we'll discuss it next class. This last page I have put up on the website if you want to copy the blank, otherwise you can just copy it out yourself. So the means, confidence intervals, and t-procedure conditions. First I want to introduce a new word, robust. You might know that from outside of statistics. The word outside of statistics means sturdy or strong or something able to withstand changes. And so a procedure is robust if the calculations remain fairly accurate if a condition is violated. And here, so that's robust. T-procedures are not robust against outliers. Okay. So if you have outliers, you're going to have troubles with t-procedures. So we have new normal conditions for t-procedures based on sample size. If the sample size is greater than or equal to 30, that's a large sample size. And the central limit theorem says sampling distribution is approximately normal, and so we can use t-procedures even if the sample is skewed. For medium-sized samples, so n is greater than or equal to 15, at least 15 in other words. T procedures can be used except if outliers or strong skew in the sample. And finally, small sample size, in other words, where n is less than 15, we can still use the T procedure. T procedure can be used under conditions if the data appears to be close to normal. In other words, there's no skew, it's roughly symmetrical, single peak, no outliers. All right, so that's the end of the new material for Chapter 8. At the bottom of this page is the homework, so page 518. You've got a number of questions there. So we'll be working on that in class. If you'd like to get a head start, that's great. All right, see you later.